Hello everyone, my name is Basma Shaya and today I'm going to be explaining my approach for modeling the Beijing library by Snohetta parametrically using Grasshopper for Rhino. To start off as an introduction, it was constructed in 2023 and is located in Beijing, China. The concept is to create a reading landscape with sculpted hills, valleys, four-stack columns, all inspired by the traditional ginkgo trees. The way I'm going to be approaching this modeling is by creating 4 different phases: the facade, the columns, the interior, and the roof. To start off with the facade is actually created by 2 different materials, the terracotta triangular panels and the zigzag glass walls. Now hopping onto Grasshopper, the first thing that I did to create the facade is create a rectangle with rounded edges, then used both area polar and chatter to extract the lines for gate A, gate B, the right side and the left side. And then to create the base for the terracotta panels, I took the sides, divided them, manipulated them in the graph mapper to create the interpolated curve that acts as the base for my terracotta panels. I did the same thing for the left side. And then to create the actual panels, I used the quads panels battery culled to create the hit and miss. And then I took the points that are intersecting with the base to take these offsets, and then I pulled out the middle point, merged those lines to create the loft, and this gave me the final result. And then to create the zigzag glass panels at the top, I took the curves from the terracotta panels, extruded it, and then I created a sweep to split the glass panels, and then this was the final result. And then for the gates, I took the gate lines, divided them, and then I manipulated them with the graph mapper, and then I got this interpolated curve. As you can see, it's a curved gate. And then what I did is I used the weave battery to create the polyline and extrusion. And this was the final result for my facade. Moving on to the most important feature of this library, which are the columns. As you can see, there are 2 different types of columns, the interior perforated columns and the exterior unperforated columns. The 2 most important features of this column is the petal shape that is existed at the top and the ascending thickness from bottom to top. So as you can see, for the columns, I did 3 main trials to get to the result that I wanted. So what I did is I used Mesh UV, Project, and Cull for the first trial. I did a basic loft, and then what I did is convert it to a Mesh UV and project the areas of the faces so I could extract them by having this curve, taking the points that are not in the curve and culling them to create this canopy-like structure. And then I separated the trunk and the shaft to create the perforations, and then I joined them. And then, as you remember, the columns actually have differentiating thickness from bottom to top. So I was trying to experiment with that. The first thing that I did is create the normal thicken, and it didn't give me the result that I wanted. And then what I did is separate the shaft from the trunk. The shaft, I extruded it to get this ascending effect of this thickness. And the trunk, I thickened it as normal. But as you can see, there was this intersection that I didn't like, and it wasn't flowing as well. And then the second thing that I didn't like about this column is how it's cut up short and the columns are actually petal shaped, so I was trying to create that. What I did is used loft and split surface for my second trial. I took the points and I created these 2 curves. These 2 curves actually gave me this column, and what I liked about this is the flexibility that I had to create different types of columns. And these were the final trial, which became the final and closest resemblance to the actual columns in the real building. So how I did them is I took a point and I created the same steps to create the loft. But the difference that I did here is I took the shaft on its own, and then I created the line out of the points as I did before, which gave me the cutting curves for the splits. And what I did is create an upper shaft and a lower shaft. This was the lower shaft, and this was the upper shaft to create the differentiating thickness. And then I lofted them by creating the naked vertices. And what I did is I took the ends to create the trunk, and this gave me the final result. And then I merged them together, lofted the edges, and this was the final result. And then I did the same thing for the outer basic columns, but the only difference is that I took the mesh without any of the perforations, and I did the exact same steps to create the final result. As you can see, the reason why I chose this is because I have the differentiating thickness from bottom to top, and I could actually change the columns to become one petal. And now moving on to the interior is actually created by these four main hills and separated by this distinct path. There are two flat surfaces that are resting places, which are existent here and here. Now it is important to mention that for this part of the video I used Kangaroo 2. So first of all, I took the gate A and the gate B cutouts, and then I took the midpoints and created a line. I manipulated the line by a graph mapper to create the baseline for the hallway. And then I took circles and I scaled them accordingly to create the differentiating thicknesses. And then I lofted and extracted the curves. And then I joined it with the right offset and the left offset to create a boundary surface. And then I evaluated the pinpoints of the hills and I moved them to anchor them. And this actually gave me this result. But for the flat surface that I was talking about, what I did is I used the area polar as I did before, and I took the points and got the left flat surface and the right flat surface, and then I manipulated the line with a graph mapper as I did before to create this curve, and then I located the points that are inside the curve and I anchored them. And this was the result for the opposite side. And the reason why I did this main curve is because I could actually manipulate the hallway as I want. So I could change it, and the whole mountains would change with it as well. And now one of the most interesting features is the roof. As you can see, the roof is basically created by these random petals that are scattered everywhere, and every column has a skylight that is above it. As you can see, these are the skylights, and there is an atrium for the hallway. These are the skylights at the top view where you could see that they are inflated, and I used Kangaroo 2 to do that. So the first thing that I did for the roof is create the petal shape that is at the top. So what I did is I took the same cutting curves of the columns. I shattered the top circle to create this curve, and I joined them and projected them to the ground to create this shape. And then I created a boundary surface out of it, converted to a mesh, and then extruded to make it lighter. And then, as you can see in this top view, there are two surfaces that I wanted to create, the inner surface and the outer surface. So what I did is I took the curves that I had before, I joined them, and I offsetted a surface, split the surface to get the inner surface and the outer surface. The second thing that I wanted to do is create the holes that are at the top of each column. So what I did is I took the top circles of the columns, and then I oriented them and created the holes in the surface. This is for the outer surface and this is for the inner surface. And then I used Pop 2D to place the petals, and I used random rotation and random height to create this effect of these petals. This was the inner first part of the roof and then the outer part. And then for the skylights, what I did is I wanted to create the shapes. So I took the curve of the hallway to create the atrium skylights. And then I took the top circles, oriented them, and then I created a bounding rectangle. And then I exploded and created this shape. And then I rotated it randomly. So how I created the skylight is I basically took the curves and then I made it into a boundary surface, converted to a mesh, and then I just anchored the naked vertices. And this actually gave me this result. And then lastly, for the structure, what I did is I used a structure beam plugin to create the first structure and the second structure. And then I split them so they would be inside the parameter of my roof. And now, this is the final result of my building. By simply changing the radius of the rectangle, the building can actually shift from a rectangle to a circle, making a drastic parametric change.